Let's write the balanced net ionic equation for lead-2 acetate plus sodium sulfate. And sometimes this lead-2 acetate, you'll see it written like this, where the acetate ion is CH3COO. Same thing over here. It's the same acetate ion, just written a little differently. So we'll use the one above here. To do this, first we must balance the molecular equation. When we look at the molecular equation, we have two acetate ions here, but only one here. So let's put a 2 in front of the sodium acetate. That balances the acetates. We have two sodiums. We have a sulfate here and here. Lead, lead. So this equation, it's balanced. Now we can write the state for each substance. That'll look like this. Compounds with the acetate ion, they're very soluble. Compounds with sodium are very soluble. And sulfates in general are soluble with a few exceptions. And one exception is this lead-2 sulfate is insoluble. That means when these two substances react, this will be a solid. It will fall to the bottom of the test tube as a precipitate. So we have the states. Now we can split the strong electrolytes into their ions for the complete ionic equation. That looks like this. So now we can cross out the spectator ions. They're on both sides. So in the reactants here, I see that I have two of these acetate ions. Also have two of them in the product. So those are spectator ions. Cross those out. Two sodium ions in the reactants, and in the products, spectator ions, cross them out. What's left? That's the net ionic equation for lead-2 acetate plus sodium sulfate. Let me clean this up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation. We have a 2 plus here and a 2 minus. That adds up to a net charge of 0. This lead-2 sulfate, it's neutral, so it has a net charge of 0. So the charge is balanced. If you count the atoms up, they're balanced too. This is Dr. B with the balanced net ionic equation for Pb, C2H3O2 2 plus Na2SO4, lead-2 acetate plus sodium sulfate. Thanks for watching.